welcome back. This is Mrs. Wigger again. Today we're going to go over parts 2 and 3 of your summer assignment. In part 1, we went over the basic commands of the TI-84 Plus graphing calculator. In part 2, we are going to get to know the free online graphing calculator called Desmos. We're going to start by clicking this link. The first video we're going to watch is the intro video to the Desmos graphing calculator. This video is about 2 minutes long. Once you finish that video, you can scroll down and see that there are other videos that you can watch. We are not going to watch all of these videos. We are going to watch these 8 videos listed. The first one we're going to watch is the points video. So the videos are listed in alphabetical order. If we click on the points video and start this video, this one is about 1 minute long. Once you have finished watching all 8 of these videos, you can go on to the practice worksheet where we will do 2 quick activities. So to pull up the graphing calculator, you can click on this link, or under a Google search bar, search for Desmos, and click on Desmos Graphing Calculator. So the first activity is to plot a point in all 4 quadrants on the graph. Quadrant 1 is when x and y are both positive. When x is negative but y is positive, that is quadrant 2. Quadrant 3, both x and y are negative. And quadrant 4, x is positive, y is negative. Here is an example of a point in all 4 quadrants. So if we pull the graph back up, if I want a point in quadrant 1, I need 2 positive values. I can check this box to turn the label on. At a point in quadrant 2, I need a negative x and a positive y. Quadrant 3, both x and y are negative. Quadrant 4, positive x, negative y. I now have a point in all 4 quadrants. Activity 2. We're going to type in y equals mx plus b. When you do that, the option to add a slider will come up. We want to add all sliders. M represents the slope of the line. B represents the y-intercept on the line, meaning that is where the line appears on the y-axis. If I hit the play button on M, we can see that as the slope changes, the line is rotating back and forth. If I pause that and play B, we can see that the line is moving up and down on the y-axis. Pause that. What we're going to do is change the restrictions on the slope and the y-intercept. We want to put the slope between -1 and 1 with a step of 1. We want to change the y-intercept to be between -5 and 5 with a step of 1. Now if I play M, we can see that there are 3 slopes: +1, 0, and -1. If I play B, we can see that this line is moving up and down. Once you have finished those 2 activities, you're ready to go on to part 3. Part 3 of your summer assignment starts with vocab and ends with solving one-step equations. An equation has an equal sign. The first example is an equation. We have an equal sign. The second example is an equation. We have an equal sign. The third is not an equation. There is no equal sign. An expression is a collection of terms. There is no equal sign. The third example is an expression. There is an expression on both sides of the equal sign. So 3x plus 5 is an expression. 20 is an expression. In example 2, 3x plus 6 is an expression, and 12 is an expression. Terms. A term is made up of coefficients and variables. Terms are separated by positive and negative signs, so they are separated by the addition and subtraction signs. In the first example, 3x is a term, 5 is a term, and 20 is a term. In the second example, 3x is a term, 6 is a term, and 12 is a term. In the third example, 2x is a term, 4y is a term, and 9 is a term. A coefficient. The coefficient is the number in front of the variable. There is always a coefficient. The coefficient of 1 is not written, but it is still there. So here we have a variable term, 3x. The 3 is the coefficient, the number in front of the variable. Again, we have the term 3x. The 3 is the coefficient, x is the variable. Here I have the term 2x. 2 is the coefficient, x is the variable. And I have the term 4y. 4 is the coefficient, y is the variable. Coefficient is the number in front of the variable. A variable is a letter standing in for an unknown number. Again, a variable is a letter. It can be any letter of the alphabet. The most common XYZ or ABC. So here we have variables of x. Again, we have a variable of x. Here we have a variable of x and y. And finally, a constant. A constant is a standalone number. It is not attached to a variable. So in the first example, 5 is a constant. 20 is also a constant. In the second example, the constants are 6 and 12. And in the third example, the constant is 9. Let's go on to solving one-step equations. To solve one-step equations, we need to know the addition property of equality, subtraction property of equality, multiplication, and division properties of equality. So starting with addition. The addition property of equality says that if the same number is added to both sides of an equation, the two sides will remain equal. So in blue, if A equals B, then A plus C equals B plus C. So if we add the same number to both sides of the equation will remain equal. So for example, I have x minus 5 equals 10. If I add 5 to both sides of the equation, I will have x equals 15. To check that equation, I'm going to sub 15 in for x, and in fact, 15 minus 5 is equal to 10, so our equation is balanced, 10 equals 10. Subtraction. If the same number is subtracted from both sides of an equation, the two sides remain equal. So if A equals B, then A minus C equals B minus C. The example, x plus 5 equals 10. If I subtract 5 from both sides, I'll get x equals 5. If I sub x equals 5 back in to the original equation to check, I get 10 equals 10, meaning my equation is balanced. Multiplication property. If the same number is multiplied by both sides of an equation, the two sides remain equal. If A equals B, then A times C equals B times C. Example. I have x divided by 5 equals 10. If I multiply both sides by 5, well then on this side I get 5 divided by 5, which is 1. And on the right hand side I have 5 times 10, which is 50. So I get x equals 50. To check that, we're going to sub it back into the original. I'm going to replace the x with the 50. 50 divided by 5 is in fact 10. Division. If the same number is divided by both sides of an equation, the two sides remain equal. If A equals B, then A divided by C equals B divided by C. Example, 5x equals 10. If I divide both sides by 5, then on this side I have 5 divided by 5, which is 1, equals 10 divided by 5, which is 2. To check, I'm going to take x equals 2, sub it back into the original equation for x. 5 times 2 is in fact 10. Let's do some examples together to practice these properties. The first example, -3 plus x equals 6. The goal is to get x by itself, so I want to move the number away from x. If I want to get rid of -3, then I need to add 3. If I add 3 to the left-hand side, I need to add 3 to the right-hand side. -3 plus 3 is equal to 0. So I have 0 plus x equals 6 plus 3 is 9. 0 plus x is just x, and I get x equals 9. Let's check our work. If x equals 9, then when I sub it back into the original equation for x, I should get both sides of the equation to equal the same number. -3 plus 9 is equal to 6. The other side is equal to 6. Our equation is balanced. Number 2, x plus 4 equals 11. I want to leave the x where it's at and move the 4. Since I have a positive 4, I need to subtract 4 from both sides. Plus 4 minus 4 is 0. 11 minus 4 is 7. X plus 0 is just x. So I get x equals 7. Let's check that. If I sub 7 in for x into the original equation, then I have 7 plus 4 equals 11. Well, 7 plus 4 does equal 11. I get 11 equals 11. My equation is balanced. Number 3, I have x divided by 2 equals -7. To move a number that's in the bottom of a fraction, I need to multiply both sides by that number. So on this side, I have 2x divided by 2 equals -7 times 2, which is -14. 2 divided by 2 is just 1. So I get x equals -14. Let's check. My original equation was x divided by 2 equals -7. If I sub in -14 for x and bring down the rest of the equation, on the left-hand side I have -14 divided by 2, which is equal to -7, which is equal to the right-hand side of the equation. -7 equals -7. My equation is balanced. Number 4. I have 5 times x equals 25. So to move this 5, I need to divide both sides by 5. I get 5 divided by 5, which is 1. So I have 1x equals 25 divided by 5, which is 5. So I get x equals 5. If we check that, the original equation is 5x equals 25. I'm going to replace this x with the x I just got, which is 5. 5 times 5 is 25. So I have 25 equals 25. I have a balanced equation. Number 5. I'm going to show you 2 ways to solve this equation. The first way I'm going to show you to solve this equation is multiplying by the reciprocal. Right now we have 2 divided by 3, x equals -6. Well, if I multiply both sides by its reciprocal, The reciprocal means flipping the fraction. If I multiply here, 3 times 2 is 6. Again, 2 times 3 is 6, so I have 6 over 6x equals negative 6 times 3 divided by 2. 6 over 6 is just equal to 1, so I have x equals negative 6 times 3 is negative 18 divided by 2. Negative 18 divided by 2 is equal to negative 9. That is one way to solve this equation. I'm going to rewrite the equation. 2 over 3x equals negative 6. Another way to solve this equation is by taking it one step at a time. The 3 in the bottom, to move it to the other side, I need to multiply both sides by 3, as we did in example 3. So if I multiply both sides by 3, on the left-hand side, I have 2x, and on the right-hand side, I have negative 18. Now I have 2x equals negative 18. To get rid of the 2, I'm going to divide by 2. 2 divided by 2 is 1. So I have x equals negative 18 divided by 2, which is negative 9. Now let's check that negative 9 is in fact the solution to this equation. We started with 2 over 3x equals negative 6. So I'm going to sub negative 9 in for x. So the first step here is to multiply 2 times negative 9. 2 times negative 9 is negative 18, divided by 3. Negative 18 divided by 3 is negative 6. So I have both sides equal to negative 6. My equation is balanced. So what we did here was multiply by the reciprocal. What we did here was multiply by 3, the denominator, then we divided by 2, the numerator. You can use either way to solve this type of equation. If we look at the practice for part 3, you'll see number 1, you're going to fill in the blanks. 2, 3, 4, and 5. You're going to first determine if it's an equation or expression. You're going to write the term separated by a comma.